אני נותן הרבה הרצאות לקהל הרחב על בינה מלאכותית, ותמיד חוזרת שאלה אחת עוד פעם ועוד פעם. תגיד, ה-ChatGPT הזה הוא באמת מבין או שזה משהו אחר? לפי האורח שלי היום, התשובה היא חד משמעית לא. לאורח שלי קוראים פרופסור וליד סבא, והוא פרופסור לבינה מלאכותית ב-North Eastern University. והוא מתעסק בייחוד בצדדים הפילוסופיים של בינה מלאכותית. מה זה אומר להבין, מה זה אומר בינה, כל הדברים הללו. ולפי דעתו צריך לעשות הבחנה מאוד מאוד משמעותית בין שני תחומים שונים. התחום הראשון הוא NLP או Natural Language Processing, שאלה הטכניקות שאיתם אנחנו משתמשים כדי לאבד שפה ולנסות לתת את התשובות הטובות ש-ChatGPT נותן. אבל יש תחום אחר שנקרא NLU, Natural Language Understanding. מה צריך לקרות כדי שנגיד, המודל הזה באמת הבין מה שדיברנו איתו. וכאשר מדברים על הבנה, מדברים על טכניקות אחרות לגמרי. אבל אל תפחדו מהמונחים הטכניים, NLU ו-NLP, זאת הייתה שיחה פילוסופית שמותאמת לכולם. למעשה היה שם קטע אחד שדי ריגש אותי, שאני הולך עוד לקחת אותו ולזכור אותו הרבה מאוד זמן. תגידו לי אם אתם יודעים לאיזה קטע אני מתכוון, ותכתבו את זה פה בתגובות. שלום לכולם, לי קוראים רועי יוזביץ', ובערוץ הזה אנחנו מדברים ביותר בעולם בשלל נושאים כמו בינה מלאכותית, אינטליגנציה, פילוסופיה, אומנות ועוד. אם השיחה הזאת מעניינת אתכם, אז קודם כל יש לי הרבה שיחות על בינה מלאכותית, ודבר שני, כנסו לערוץ, תראו מה אנחנו עושים, תירשמו, תיכנסו לטלגרם, יש לנו מפגשי עוקבים, תהיו חלק מהקהילה המדהימה. השיחה הזאת היא גם במימון הערוץ של יוזביץ', אז אם אתם רוצים לתרום, אתם יכולים לעשות את זה דרך רכישת קורסים דיגיטליים, רכישת ספרים ועוד דברים, כנסו לאתר ותראו. ועכשיו, פרופסור וליד סבא. דוקטור וליד סבא, thank you so much for coming today. How are you?
I'm very good. Thank you for this opportunity. Thank you.
I think it's going to be a very interesting conversation. It's not going to be just about the technical aspect of NLP and NLU. It's going to be about the philosophical aspect, which means that it's going to be much more interesting for me, at least. I want to start with something that we rarely talk about in university. You came to or you returned to Northeastern University after being in the tech industry for many years, and you were the CEO of a company, and you had startups, etc. And more often than not, I think that what we researchers in the AI community or in the university lack is a true understanding of what happens outside in the real world. And I think that a perspective of someone who was in the real world and know the limits and know how to write code in a way that it can be manipulated 2 years after is a tremendous advantage. So if you can please elaborate on the concept of being just in the university and being outside in the tech industry.
Very good question, actually. I had the same experience in reverse years before. I went to academia as a tenure track faculty after I was for several years in Bell Labs and IBM. And students can notice that this guy has been in industry. This guy is not a typical professor, finished PhD and went and stayed in academia, basically. And yes, you can learn a lot by working on real projects where you have to cut corners and not be so elegant and so pure and so theoretical. Building real systems, especially large systems, teaches you a lot. Teaches you real pragmatics. But at the same time, I have to sympathize with academics. Why? Because they always get a bad rap. We in industry, and I've lived, if I want to compare like all the years, 2/3 in industry and just about 1/3, or maybe less, a quarter to 3/4 in industry. But in industry, you hear this term, "Oh, academics, they don't live in the real world." And this phrase I don't like, as if academics live in some nirvana somewhere. No, they live in the real world too. And uh, the fact that academics don't have to build real products should not be a negative, because they're busy doing something else. And very few of us realize that all the technical advances that we're now living in and witnessing started out in academia. I can trace any one of them, from programming languages to compilers to even GPS. Even the root of all of these was either academia or research labs. So researchers and academics, they get unfairly, they get labeled as people that don't do the real thing. Well, there's science and there's engineering, and the real science has happened over the years, over millennia, actually, in academia, in the academia. That's so. So I'm very sympathetic to, although I worked most of my life, like I said, in industry, but I think it's unfair to put academics in such a place that they are just doing theoretical and research work, and that's not the real thing. And this trend has been more really since the big tech took over both research and development. I mean, they took over even conferences, and they took over academia. And you had people in these big tech executives saying, "Do we need a university degree? And all you need to do is get trained on our tools and our packages." And that's false. That's not true at all. Foundations that are given in a true academic setting are very crucial.
I want to weigh in just a second. Yeah. And I had Bjorn Stroustrup, the inventor of C++, on the show a few years ago, and he started his career in the Bell Labs. And I asked him, is there any possibility to duplicate the concept of the mythical Bell Labs of the 40s and the 50s? And he said, I don't think so. And my question is, because you said everything starts at either in academia or in research group, and the famous paper that started the entire GPT thing, attention is all you need. The first papers that introduced transformers was introduced by research, by Google research team. And my question is, can you make a distinction between research that conducted in university and research conducted in Google Research Lab, Apple Research, Microsoft Research, etc.?
Right. Very good point, because you mentioned Stroustrup, the C++. Because there's Google Research and there used to be Bell Labs Research, and they're both companies. And he's absolutely right. The Bell Labs ecosystem doesn't exist anymore. At Bell Labs, you were literally between being a researcher, a pure faculty researcher, and with one foot in industry. Right now, what they call research at Google is not really research, pure research. What I mean is, yes, attention is all you need was the beginning of the transformer architecture, and we know where that led. But the foundational idea behind it is not the product of Google. That the transformer architecture is an engineering development, not a scientific development. What I mean is, let me see if I can put it in. All the advances in large language models, starting with attention is all you need, and even before with LSTM and even way before with GloVe and Word2Vec and all that, is really, I'm trying to do categorization at a very high level here. If I want to put all that in one classification, it's based on the distributional semantics hypothesis, basically approximating the meaning of words by vectors in a vector space. That, okay, on top of it, we had engineering and smart ideas, but essentially the fundamental, if you want to think of it as a paradigm, as a conceptual framework, it's all based on embeddings, and these embeddings are a function of co-occurrence in the corpus as, yes.
Just a second, for our viewers who are not familiar with the concept of embedding, okay, I'm not going to explain it because it's but I'm going to just give you the gist. The idea is, can I take a word out of a dictionary and convert it to a point in a
multi-dimensional space.
Multi-dimensional space. This is basically the concept of embedding. And then what will happen, that I can take two words and those 2 points in this many dimensional space, and then I can measure the distance between two words, and then I can think about similarity. So basically, you know, a dog and a canine, yes, canine will be relatively close, okay? Because canine is basically one
type of
one type of
they're in
dog,
the same family, right?
Yes, definitely. Okay,
perfect description in a few seconds, and it's a brilliant idea. Because why it's a brilliant idea? Because now I can compute with meanings. I converted words into mathematical objects that I can manipulate. I can add and subtract and do similarity with them. So it's a brilliant idea. Now I can compute with meanings, basically, mathematically. So, but that idea can be traced back to even decades before, the idea of embedding or a vector, basically represent the meaning of a word as a vector in some space. And that came from research. So my point is, there's scientific innovation, an idea, a concept, the idea of representing the meaning as a point in some space where all the dimensions are different features of the meaning. We call now embedding. And the engineering after, okay, the LSTM, Word2Vec, GloVe, oh, BERT is better, and then LSTM, and then transformers, okay. That's engineering. But the fundamental conceptual idea, you see what I'm getting at? I'm trying to differentiate between science and technology, between engineering and foundational research.
I think that, you know, I try to listen carefully to what you are saying, okay? And we have King Solomon, you know, in the Bible that said there is nothing new under the sun, okay? And you can take this interpretation in many ways, okay? We have iPhones, and King Solomon didn't have iPhones. So what is the meaning of nothing new under the sun? You know, one can say, okay,
but actually, in defense of King Solomon, as if he needs defense, but conceptually, it's a matter of how abstract and high level you want to go.
Definitely.
At a very high level, a phone is a way of communication. We had way of communicating. We had pigeons.
Yeah, definitely. In a way, we know, you know, the best thing about King Solomon is we know that God said he's the smartest man ever lived. Okay, so if he said something, we know for sure it is at least very, very probable to be correct. So we can say in the in the higher sense, phone is just a method of communicating, okay? And we had this a concept of communicating. Now you said, okay, listen, the scientific part is the concept of embedding, okay? And everything beyond, everything above is engineering.
Is technology. Yeah.
Okay, and you know, in my opinion, one can put the barrier a little bit higher, okay? I think it's just a matter of personal taste. Where do you put the barrier, okay?
Right,
so
right.
Now
and sometimes it's very difficult, actually.
Definitely.
Yes. Yeah.
Let me put it differently. Sam Altman and Ilya Sutskeberg from OpenAI were in Tel Aviv a few months ago, before the war started, and they they spoke about, you know, the connection between academia and industry. And Ilya Sutskeberg, who speaks Hebrew, by the way, was asked by the audience, what is the role of academia nowadays that we have OpenAI? And he said, you know, academia cannot compete with the big tech and cannot compete with OpenAI, but you can't be in academia in the bleeding edge of technology, because the bleeding edge of technology demands resources and money and computing power most academias just lack. And I had Elad Hazan from Princeton University, and he said, we need Google to come and help us with the GPU. But what academia can do is to make sure that our path is correct, is to understand more profoundly what we are doing here.
You're gonna hear,
yes.
You're gonna hear probably an unpopular point of view on this. The headline is I disagree, but I'll tell you why. Yes, look. Let's assume this is correct. If you extract all the great ideas that are now ending up in products, from the smartphone to GPS, which I can't live without anymore, to all the amazing technologies we have. If you extract all the foundational stuff that this thing lives on, and there are so many, I mean, just imagine wireless communication. This happened by research of how packets can be transformed over the ether. I mean, there's lots of foundational work that led to this. If you extract all that stuff out, and we live in the Google world, or in the OpenAI world, or and we shut down academia, and we shut down all this foundational research, what about the next 50 years? Where's that food gonna come from? Like, we're living now of a lot of foundational work. It's like in the old days, they used to store food for the winter, right? Okay. The winter is over, and you didn't store anything for the future. Where's that stuff gonna come from? You think it's gonna come out of Google and Amazon? No. That foundational work. I'll give you just compiler technology. We worked on type theories and polymorphism, and we worked on interpreters, and we worked on in networking. Oh my God, we worked on algorithms for optimizing traffic over the network. And these were theoretical algorithms. I mean, we worked for years on the theoretical complexity of it. Okay. And now we take it for granted. And for us, it's a package. And okay, what about the next 50 years? Where's that food going to come from? Where's that? Now we're living in heaven because we have so much that great researchers have worked on. Where's the next 50 years or 100 years? Where's the next advancement? Just more tweaking of the tech we have? Then it's a closed word assumption, and we're stuck with this, and that's it. No more innovation. This is a very commercial, consistent with the world we live in now. Everything is commercial. Everything is judged by the gadget that I can produce in a few months. But this is sad, in my opinion, because we're gonna see the effect of that in few years. We're gonna say we're blanking out. We have no more ideas. Well, because engineering doesn't come up with ideas. Engineers, Albert Einstein never made an experiment. They never bothered.
Only Gedanken experiments.
Yeah, but he was a scientist, not an engineer, not a technician. So, but the great ideas come from science. Actually, they come from philosophy even before science. And I today or yesterday, a colleague of mine told me we have a thing called Ask Me Anything, and it's like a round robin, and my turn came, and students asked me questions, and in my answer, I advised some of them to read philosophy. And a colleague of mine came and he said, "You're the only one in AI probably today that will say read philosophy." I said, "Believe me, all the answers are there. They are not in a PyTorch library, not in TensorFlow, and they are not in import blah blah blah. That's the easy stuff. That's for kids. The real solutions and the real ideas will come from." So I'm very
I
passionate
couldn't agree
about
with you
this.
more.
Yeah.
I couldn't agree with you more. I had a conversation yesterday with Ken Stanley from OpenAI. Now he's at Maven, and we just discussed philosophy, you know, the open-endedness concept. And his book, Why Greatness Cannot Be Planned, was about philosophy that just stemmed from the concept of AI. So I totally understand. And by the way, if I want to strengthen your point, the idea is that this is why Belab could not repeat itself, you know, because what Bjorn told me that in the end of each year, a researcher could come to his supervisor and the supervisor would ask, "What have you done this entire year?" And the researcher said, "I was thinking. I just thought for 1 year." And even now you can do it in academia, but of course you can do it in research labs. So basically in the concept of research versus development, research labs are not pure theoretic. And they are lean towards, okay, what can be done? And another thing, which I think is tremendously important, because I grew up in a robotic laboratory in academia, the idea is that if someone knows something, humanity already possessed this knowledge. Like if Boston Dynamics managed to do something, it says nothing about my laboratory. The idea is that you need, you know, to diverge the knowledge, you know, to spread the knowledge. Because if what Boston Dynamics, the knowledge of Boston Dynamics could be replicated to any robotic laboratory in the world, humanity would be
progress will be exponential.
Yeah, definitely. But it's not the case, and it was never the case. Okay. And this is why it is so hard sometimes to replicate research papers. Okay. And this is why, you know, papers with code is so important. You know, just take my findings and go on from there. Would you agree?
Definitely, 100%. Right now, I mean, you know, it depends on our values and what our goal is as a humanity, as a society. Is it to advance knowledge and seek knowledge and distribute knowledge, or is it to create something that will be monetized for a group of people? I mean, and these two are, no matter how much we want to beautify, I don't want to say capitalism, but no matter how much we want to put a nice spin on it, these two are contradictory, okay? The good of all is not consistent with the good of me, okay? By definition, logically, okay? we don't want to get into politics, but
I think it's
these
not about
two,
politics even. I think it's even about philosophy or
it's a fair,
religion,
yes, yes,
the idea of, I live as an Orthodox Jew in a very contemporary modern world. And the
right,
idea and the idea of science ever since the Renaissance is,
right,
we focused on the self, on the individual. But
right,
we know from experience that true happiness cannot be gained just by looking inside. If you
inside,
want true happiness, you need to go outside.
right,
You need to
right,
put the other as your focal point of attention. So
exactly.
yeah, I can't agree with you more.
Yeah, and unfortunately, um, and that's what saddens me in some. And I've written about this in few blogs that I mean, academia was the last sacred place left that's not polluted by this. But we even got to that, and but I feel very strongly about this, very passionately, that we should counter that somehow as academics, as scientists, as thinkers, as philosophers, as people who care about advancing societies in general, right? The, this, the dissemination of knowledge and the creation of knowledge should not be commercial, should not be driven by I own this and you don't have access to it. Like, what does that mean? Uh, it it's really sad, and I don't think this will advance science. In the end, it's a self
Destructive.
destructive strategy, because in the end you will discover that we're not doing any more foundational stuff that we thought is waste of money. Okay, how do we feed the next uh, uh, 50 years or century of stuff? Now we're living off an amazing century of amazing discoveries from Alan Turing and Frege and Emil Post and von Neumann. And oh my God, they have
We
created for us so much
we eat
conceptual. Yeah.
we eat the leftover of a giant dead whale. And
Yes.
what will happen when the dead whale will end? Okay?
and
We
it will
need
end,
we we
and
we, we need to find a new
right,
whale.
and it will end no matter how big it was. And I mean, if you think about all the stuff that we came up with in the 40s and even before, from the 1800s, really, I mean, there was from the days of Russell and Frege and Emil Post and finite state machines and the nature of computation. And then uh, here's an analogy that will probably resonate with some people. What we call now deep learning, do you know that it's not that much advanced than the idea of McCulloch and Pitts of neurons firing and adjusting their weight and training? The rest is engineering. Roy, if you appreciate what I'm trying to say, what I'm trying to say is there's so much we still don't know. Are we allowing people to extrapolate and examine these ideas? No. Use this library, use this. This is, I'll give you an actual example. A friend of mine, his son wanted to do masters in cognitive science. He couldn't find an advisor. If you don't stick to this paradigm, import these libraries. This is the data set. We have benchmarks. And it's like there's a template, benchmarks, test analysis, few tables at the end. That's science. We reduce science to beating the state of the art by 0.01%. What happened to new ideas? We're yeah, I'm probably too passionate about this, but you cannot hijack science and thinking and innovation. What happened to a guy sitting in a cafe taking out a napkin and getting an idea and on the napkin and like now it's import this library. What?
I just want to tell my viewers that if you find what Dr. Walid resonate with you, please check out my conversation with Rupert Sheldrake, who wrote a book named Set Science Free, which is exactly about this
I love it.
in the context of physics, chemistry, and we know that we have this convention of science, we have these dogmas of science that we need to believe. And if we set science free, maybe we can find something else. So with your permission, I would like to go to, the foundations of things. I had many talks in this show about NLP, which basically, there are two terms of NLP. There is our NLP and there is Richard Bandler NLP. And the guy who knows about, the group that's familiar with the natural language processing is unfamiliar with neuro-linguistic programming and vice versa. But we know what NLP is basically. But there is another term called NLU, which is natural language understanding. And natural language understanding build upon, above NLU, but it can be the foundations. But basically, nowadays, I might argue that ChatGPT doesn't need to have NLU or natural language understanding, just natural language programming. Nevertheless, it produces great results. So please, what is NLU? If you can give a concrete example, and do we even need it? And in the strict sense of making ChatGPT better, and in the larger, broader sense of what we talked about, the foundation of science.
Okay, this is very dear to my heart because forever I keep telling people NLP is not NLU and NLU is not NLP. And I don't know what the relationship between them, which subsumes which. I don't think that's the relation between them. The relation is more complex. NLP for me is text processing. Any processing of language is language processing. So if I take a document and I extract from it, I don't know, all the locations, then I'm doing some processing on a body of language. So I'm doing language processing. So language processing is any processing of language. Language understanding is a different beast. For me, language understanding, at least the holy grail that we're after, is to build machines that can communicate like us and understand each other. That's the word, understanding. And what does understanding mean? Again, people say, but define understanding. Well, when it comes to language, understanding is not so ambiguous. For me, understanding in language is this. The reason for language is I have a thought, an idea, something I want to convey. I can't convey the mental picture I have in mind, or like Jerry Fodor calls it, the language of thought.
Yet.
Or the mentalese. It's
yet.
Yet. I like that. Yes, I agree. Okay. So in my mentalese, in my language of thought, I have an object, a mental thought I want to convey to you. Okay, we invented English and Danish and Chinese and Persian and I'm using that medium. I encode. There's an encoding decoding going on. I encode the thought into that external artifact we call German.
And we call this process articulation, yes? Yes, the idea of conveying the mental image into text that can be comprehensible to other person. We call this process basically articulation. The better, the more articulated you are, yes.
And that's why sometimes you say he's not good at articulating his ideas. Exactly. And that, but technically what we're doing is encoding. We're using it's a language to language encoding scheme. We're saying, okay, we don't know what mentalese is yet, but I encode it in German, and a German listener or reader is now on the other receiving end. And actually, you can apply Shannon's information theory of message sending on this. And then you do the reverse. You decode the message and hopefully arrive internally at the same thought or similar to the thought I was trying to convey. If your internal thought that you decoded is close to the thought I was trying to convey, then you understood me. Okay, all this means what? Means understanding is really, I have a thought, I'm sending it to you. Did you get it? Did you capture it? Or something close to it. It's not going to be exactly the same. And that's understanding. So
I want to ask two questions.
Yes.
Just a second before you continue. The idea of well-articulated people versus bad-articulated people means that the conversion, that the functions that convert your mentalese into text is
Right.
not an objective one-to-one. Yes, it is
point.
much more complex, and there are many ways to translate one mentally into text.
Of course.
And the idea is, okay, so the concept of articulation, okay, is so profound. And the idea, and the other things that I want to raise up is, we don't know. I don't know whether you understand me or not. This is in cognitive science called the theory of mind. The idea is that I don't have any representation of your mental self, and I don't know, the basic, very simple example that I don't know if if me perceiving the color red is the same as you perceive the color red. Maybe you perceive the color red differently, and I will never know how you perceive the color red, okay? So basically, what we know, and this goes back to the Chinese Room by John Searle, maybe I don't know what is your mentally, but if you act and behave in the real world according to what I said, so then I will say, yes, you probably understood what I said to you.
Too many things, and they're all important here. Okay. The idea that I don't know if you understood me or not. I think there are many misconceptions here about people say language is ambiguous and people don't always understand each other. I tend to think that we're missing something when we say understanding. We're lumping together understanding with our subjective interpretation of things. For what I mean is this: if I said Sarah enjoyed the book, everyone knows what I said. They understood it. How they interpret that thing and how they synthesize it with their own biases and history and previous memories and so on is unique. But the understanding process is more systematic than that and more convoluted than that. But to stress this point more, if we didn't really understand each other, again, our interpretation, our synthesis of things is different. You buy a book, I buy the same book. You read it, I read it. We get something different from it, both of us. But we both understood what was said, the same. What we got from it, that's a higher level interpretation of what we understood, which is the same. And then people say, but wait a minute, like you said, what the color red for you is different from what the, by the way, no two humans agree on any concept. People say, what? Yeah, we don't. The actual mental picture inside of any concept is different in every human being. Then people say, but how do we communicate? We communicate because that quantum level or that micro level difference in how I represent the mental image of something in my head. It doesn't matter. And brilliant philosophers have summarized this in many ways. And I'm actually working on symbolic large language models using that idea. I'll get to that later. But
we communicate because basically what you said is private language. The concept of private language doesn't exist. And if your interpretation of language, your meaning to words is so different and far away from the common understanding, you will not be able to communicate. This is basically there is no such thing as a private language.
But what is that common? Here's the trick. What is that common thing? And I mean, you converse with a 4-year-old, right? The image of an apple in their head, or the image of the door, or the image of the car outside is completely different from what you think about cars. There's no way that you think about cars the same way a child thinks about cars. Yet, when you say, where's mom? And they say, she's in the car. We both are communicating about cars, although the image of a car in the 4-year-old is completely different from a car for me is. The reason we're communicating is we don't care about the specific nuances of the different representation of a concept in your head is. What matters is how we talk about it in everyday life. Like a car is something we drive that has an engine that starts and can be shut off, and that thing, that common thing, forget all the nuances and differences that you have in your head about cars. Maybe they remind you of your grandfather. I don't know, but the core of a car is how we talk about it in ordinary spoken language. It's even a Kantian idea, like to know what something is to investigate how we predicate it and describe it and talk about it. So apples are things that are food because we eat them. We can say sweet, we can say it's tasty. The way we talk about something is what it is. To know what something is to know how we talk about it. Because at the quantum level, if you're going to go deep down, Jerry Hobbs said it's an unsolvable problem. We will never agree on what a concept is. So that's a futile, and that's why a lot of symbolic AI didn't succeed, by the way, because we were playing God. We were saying, this is what an apple is, and this sound concept falls under this. This is a hopeless endeavor. We can never arrive at a common conceptual representation of any concept. And I use the word apple because it can be simpler than that. A 2-year-old knows better. Yeah.
I must ask you, so what do you think about, the Chomsky hierarchy of language? So can we say that this is also our intention or our will to play God and say, okay, we truly understand, I can formulate the concept of language? So how does the concept of apple that being transformed to a symbolic math that you reject reconcile with your appreciation to the work of Chomsky?
The Chomsky hierarchy of languages is a I don't want to say it's unrelated, but it's a mathematical formulation of a class of representational systems, because languages are equivalent to machines. Like regular expressions are equivalent to finite state automata. Finite state automata. Context-free languages need more expressive power because I need to have a stack or a store. So now I have push-down automata. So the hierarchy of languages is equivalent to computational power, right? That's the and when we discover something mathematically, I don't know if we're playing God. We're discovering God. We're not inventing a God. We're discovering God. It's different in my mind. Like mathematics is something we don't invent, we discover. I'm a Platonist in that sense. Like mathematical truth exists out there. We're not
So
that important.
in your opinion, Chomsky work can encapsulate all the richness of natural languages?
I think so. Yeah.
Okay.
I'm a Chomskyan in that sense, and I'm a Chomskyan in the other sense, which is the rationalist sense. In other words, we don't uh, we don't acquire language from experience, by data, bottom up, by observation, all this data driven approach. That
We have a
is,
language instinct.
we have, and there is an innate module that we have been endowed with through evolution. I don't know how, that's a tough question. But yes, language became, there is a language organ. There's a like there's a visual system, there's a language system. And if you look at the animal species, you should say, wait a minute, neurologically, the brain of a chimpanzee is so advanced and not that far from the brain of a human biologically. Yet the difference between us is not quantitative, it's qualitative. There's like no comparison, right? So we obviously have over the years developed some modules, some linguistic machinery that and it's not an accident that language and thought and reasoning are like if and only if. They all came together, this conceptual system that we created.
So just a second, let me explain one thing to my viewers. If you're unfamiliar with this discussion, first, there is a great book by Steven Pinker, The Language Instinct, which is basically about all the proofs to in favor of the Chomskyan theory. And you can think about it very simply in this way, okay? We think in terms of words. Basically, when we think, we speak to ourselves. But how can you think and acquire language if you have no words? So basically, what you have is a mechanism or an innate mechanism that enable you to get the gist of languages. And even, grammatical mistakes that toddlers do, basically inform or imply that they understood the grammatical structure of the language. And this is one proof, and there are many other proofs. Animals that can possess, that can, you can teach animals some words, but it will be profoundly different. And just like Walid said, it's not quantitative, it's qualitative in another way. We interpret, we communicate in a whole other level.
Right. And the real it has a computational aspect to it. Amazingly, it was like, it's like one big story. The animals do communicate, but animals have a finite list of symbols or sounds that they use, and that's it. Animals don't have this productive nature that comes from recursion, that we can Jerry Fodor calls it productivity. So we can create out of our combinatorial system, we can create an infinite set of thoughts, that things that, so a child will understand a sentence that they never heard before. Animals know. Animals have a finite set of symbols. So if an animal hears a weird symbol that they never heard before, for them it's meaningless. In human language, the secret is recursion, productivity, this infinite productive capability. And our capability, people tell me, but we don't, infinity is a theoretical concept. I say, wait a minute, you use it every day on your machine. They say, what do you mean? Natural language is infinite, and we need, this is Chomsky's infinity, I like to call it. Nobody uses this term, but I call it Chomsky's infinity. When he said famously, speaking of the probability of any sentence is meaningless, is a meaningless notion. You can never predict what someone might say next. And he's referring here to the infinite nature of thoughts and thus sentences that I can make. And people say, but wait a minute, that's a theoretical thing. In practice, we don't deal with infinity. And these people are using this concept every day on their machine. I say, how many valid Python programs is your Python interpreter ready to execute?
Infinite numbers.
Infinite. Imagine
Yes.
your Python compiler saying, oh, this one is valid and everything, but it's not in my set. It's not a finite set. We have simulated infinity through recursion, right? People they've never understood what Chomsky was talking about. The number of things I might say, I might express, and thus the number of things when you are at the age that you achieve language competency. Once a child reaches that threshold, they're ready to understand any sentence. If we exclude words that they don't know what they mean, but that's a trivial thing, that's a dictionary thing. But if they know what every word means, they're ready for any sentence whatsoever. That doesn't exist in animals. Animals have a very finite set of symbols that this means this means that's a
okay. So please, since I was majored in engineering, let me, with your permission, take this engineering approach to our discussion. This doesn't exist in animals. I totally agree. My question is, please, yes or no, because there's going to be a follow-up question. Does this exist in the current version of ChatGPT?
Not at all. Not even close.
Not even close. Okay, this is great. And my question is, let's do the Turing test. What needs to happen in order for you to say, I think the GPT has some sort of NLU? Give me an experiment that I put into the GPT, and you say, yeah, I think it basically understood. And I want to relate to a recent article that you published at Medium 12 days ago. And, you know, even I didn't understand all the questions that you asked GPT. So, but it seems that ChatGPT understands the meaning and the entities of most sentences. So could you please elaborate? Why do you think ChatGPT lack NLU right now?
Okay, ChatGPT by ingesting billions of sentences, it figured out the proper way of speaking. So it found. So the reason I'm starting with that is we have syntax, semantics, and pragmatics. So it conquered syntax hands down, no problem. Actually, it can speak proper language better than most adults that I know. Okay, so it conquered syntax. Now, embedded in syntax, and that's related to the Chinese room argument, which I have strong opinions on, but embedded in syntax usually is our semantics. What do I mean? Like, because you're not going to see too many texts that says, I was arguing with the table, and we don't argue with tables. So unless it's a cartoon movie or some metaphor, but the percentage of that in this huge corpus is so small that it captured more meaningful relations. So basically what I'm saying is when we speak proper language, we are doing that because the semantics are meaningful, right? So that sentence is not only grammatically correct, but there's embedded semantic coherence in it. So GPT-4 as a side for free, it got also to learn.
So just a second, semantics in your because I'm not sure I'm not sure that neither me nor the viewers follow exactly what you say. When you say semantic, you said this. I know the grammar is correct, but this is gibberish. This sentence means nothing.
Doesn't mean anything, right?
Doesn't mean anything. Okay.
Right. Chomsky.
Although,
we go back to Chomsky, his famous colorless green ideas sleep furiously. It's very grammatical, but what does it mean? Like, okay, so semantics.
It's just postmodernism.
Yes. So, but because we don't have too many of those sentences in our corpus, GPT-4 learned good semantics, things that are meaningful also, like because our corpus by nature doesn't have gibberish, although grammatically correct sentences. There are very few. So statistically, it also captured the proper way to speak, not only grammatically, but semantically. Okay. And I've tested it on that actually. Like I say, Detroit has car factories, but near the factories, there you can still see green and plants. And I wanted to see if it captured the plant, the plant that grows, because there's a meaning for plant that correlates with factory. It actually knew that no, here you're talking about this plant, so it knew semantics, it knew the meaning of things. Now, pragmatics and reasoning is another level, and that's the deep understanding. GPT-4 does not understand language, really understand language. It captures syntactic and semantic patterns. It can speak fluently forever. Now, the question is, and I think you hinted at that, is how do you test it? Like, how do we keep saying my opinion, your opinion? No, there must be some objective way. And there is an objective way. Ask GPT-4, give it but this is a technical test. Give it a paragraph, like give it the first paragraph of the Wikipedia page of Elizabeth Taylor or whatever, and tell it, okay, here's a piece of text. Show me that you understood it, quote unquote. Show me all the entities and relations that are implicit in this paragraph or in this small document. You will see how much it didn't understand. Why this is a good test? Here you have 0 degrees of freedom. If you really understood this text, I'm not asking you to go on forever spitting out text that you memorized in all kinds of places. You speak very well because you have memorized. No, I'm asking you to show me you understood this text and you can unambiguously convert the raw natural language to entities and relations that correspond to the knowledge that is implicit in this text. If you do this test, you will not have the high regard of GPT-4 you have now.
So
I guarantee you that.
Okay, so when you say the implicit knowledge, you basically mean although all common knowledge that we get outside the text that we know from reality. I think, yeah, yes.
No, I mean, you need that common knowledge that's not ever stated in the text.
For example,
discover,
Jerry drank the poison and fell on the floor. So we need to know that if you drink poison, you are probably going to faint or die. And this is outside the text. This is a common knowledge that we get from reality.
Right. Now, you need that knowledge to really decipher and uncover the implicit knowledge in a raw piece of text to get it all right. Basically, here's the thing. If someone reads the first paragraph of Liz Taylor Wikipedia page, and they're done, I say, you're done? They say, yeah. You understood it? They say, yes. If they understood it, then they can say, Liz Taylor was born in London, England. Liz Taylor was born February, blah, blah, blah. Liz Taylor is a famous actress. They can create the knowledge structure, the knowledge graph, the triples, entity, relation, entity of what they read. If GPT-4 understood that, because that's easier said than done. The reason I did this test, because I'm working on automatic extraction of graphs from raw text. I'm working on it as we speak, and it's a difficult problem. So does GPT understand the text and can create an unambiguous formal structure of what it read? So testing it on generating text is misleading. This is not how GPT should be tested. It should be tested in reverse. Here's text. Show me you understood it.
Okay. Now,
yeah.
I want to mention two things. One, Both, I think, Gary Marcus, who was on the show, is rebooting an AI, and Melanie Mitchell I forgot the name of her book, but she has a great book. They basically stress, I think, the same thing, that there is common knowledge. Melanie Mitchell says that we need the body in order to really understand what we are talking about. But Gary Marcus say we need common knowledge. And without common knowledge that is implicit in the text, we cannot really understand. And he brings many, many examples. Okay, so this is basically the theory
I subscribe
that you propose.
to this school, but I have a slightly different slant on it. And I respect both, and I like their work. Melanie Mitchell and Gary Marcus, we communicate quite a bit. I like his opinion on this. He's a true cognitive scientist. By the way, you mentioned Steven Pinker. He was a student of Pinker at MIT, Gary Marcus. That's where he did. So, and I know he's very sympathetic to Chomsky. He knows Chomsky very well. So he comes from that school. But the knowledge that we need is not only not implicit in the text. It's not even in the text at all. I call it the missing information. This is for effective communication, we found out an optimal way of saying the minimum required for you to understand me, but not more. Actually, evolutionary biologists describe this in terms of information theoretic optimization. We agreed on an optimal way of communicating, that I don't say more than I need to. The rest, anything I can assume I don't say it. And so there's a lot of missing information. Actually, the messages we send across are so compressed. There's a lot missing that's not even in the text. Like I say, Mary enjoyed the movie. I don't have to tell you she enjoyed watching the movie. You know what I mean? Although Mary, people don't only watch movies, people direct movies, produce movies. But the missing thing here is watching. John enjoyed the cigarette. Enjoyed what? Making it? No, enjoyed smoking it. Right? So we leave a lot of stuff out because we all know what we all know. So I don't need to send that information. Mm-hmm. And that information is what GPT-4 will never get at. Why?
Okay.
It's not even in the data. So you're looking for something that's not even there.
I would like to object with your permission.
Please.
And please don't get offended, but you remind me my wife.
No, I love the debate.
You remind me my wife. Why? Because my wife tells me you need to be more involved in the house chores. And okay, I will be more involved.
And I agree with her.
Just a second. And when I'm more involved, she said, no, it's not enough. Okay. You need to be more involved. And let me tell you why I think that you are slightly unfair, because I love to read, old AI papers, and I think the original Chinese room paper, the examples, the hamburger examples that they gave there, hands down, ChatGPT can solve and understand. So basically, our interpretation 30 years ago to what means understanding in the context of AI was much more modest than what you're saying right now. So maybe you're
saying
slightly unfair. Yes,
we keep raising the bar.
Yes, I think that the Walid Saba of the 1980s would say, no, if we achieve what GPT has now, this will be NLU. So,
and
do you follow my objection?
Yeah. And I love it. You know why? This is what separates me from Melanie Mitchell and Gary Marcus, who are so negative about what happened. I am in awe of what happened. You actually are absolutely correct. If in 1988, when I was working on my master's thesis to do quantifier scope resolution, if you showed me a beast like GPT-4, I would say there is a God. What is this, right? I agree with you. I tell people, even Chomsky, when he wrote the New York Times article that says this is not anything, this is not under, I was a little bit like, I expected more from a great scientist of our time, like Noam Chomsky. Like, no, Professor Chomsky, this is not nothing. This is a huge, and it teaches a lot about cognitive processes. Like, it taught us that maybe we can learn a lot from data. Believe me, I appreciate what you're saying, and I fully am on this side when it comes to this. Anyone that dismisses what happened doesn't know science and engineering, doesn't know philosophy. This is not trivial what has happened. You are witnessing, this is an existential proof. You are witnessing, you can go and try it. You are witnessing a machine that, okay, because of scale and because of whatever the reason, we have an artifact that has, if you bring John McCarthy and Alan Turing and even Frege from their grave and they see this, they will change their mind about all their philosophies. What happened is not trivial. Believe me, I appreciate what you're saying. I come from yes, there is a but. I come from a different angle. I'm saying to equate this with AGI, first, you are wrong.
No, it's not AGI.
But yeah,
we are in the trajectory. You know, one can say,
this is where
maybe CNN or maybe convolutional neural network is the trajectory toward truly vision understanding. And you can say, I think that vision transformers. And I think, no, we still don't understand the idea of adversarial noise, that you can alter the meaning of an image just by changing some pixel. We really don't yet understand vision. Okay, but what we are seeing now.
But I'm saying more than that. I'm saying a lot more than that. I'm saying not only that we're not there yet, I'm saying that we will reverse tracks and go back to the drawing board. This is not the way even. Here's what I think will happen. I know I'm making an extreme statement. Like, people say, what? We're not even on the path with all this progress? I don't think we are. I think we have reached the ceiling of what data-driven approaches can give us. Because scale, by the way, now, GPT-5, GPT-7, GPT-20 will not be smarter at all. Actually, there's some theoretical work that hints at diminishing returns. So maybe this thing will start getting crazier. There's a limit to how much you can get just from raw data without a word model and common knowledge. So, as impressive as this experiment has been, and by the way, I was arguing for this idea in 2007, bottom-up reverse engineering of language at scale to discover how language works, but not statistically, but symbolically and conceptually. Then you have the best of both worlds. I can get into that later, but what they have achieved is unbelievable. But will this be the language understanding technology we're going to speak of, hopefully me and you, if you like, 3 years from now? Believe me, we will be talking about something else. Conceptually, even the paradigm will be different. That's the message I'm trying to get at. This is not the end of the end of science. This is not the end of the world. No, this is a great achievement. It teaches a lot, not only engineering-wise and machine learning, but even in cognitive science. It teaches us that you can get a lot from just unsupervised processing and finding patterns in data. This is a huge experiment.
In huge data, which leads me, I think, to another profound question. You know, we know that after witnessing 1 million images of cats and dog, a computer vision model can distinguish cats from dog. And we know that after seeing 1 trillion petabytes of, unimaginable numbers of text, ChatGPT reached the height that it reached. But we know also that this is not how human beings understand and capture and get. And it's, it's the theory of ideas by Plato. We don't need million numbers of images to distinguish cats from dog. It's like that we have.
You need to see 2 or 3.
Yes, true. And if I make any mistake between dog and it will not be between dog and cat. Something, which leads me. Many students of philosophy. I think that it's all a world of ideas, Plato world of ideas, because it's very stupid. But when you see how we classify, how toddlers classify dogs from cats, or it's unimaginable. Right. And maybe
with one instance, they see a cat once, twice.
Yes.
All of these are cats. Even if they see a cat, that's completely different. But somehow they got the essence of what a cat is with 1 or 2. That's it.
Yes. There is on my lecture, there is a great picture that I love so much. And the picture is dogs and muffins. Okay, so it's go like this. And you say, okay, guys, so similar, yet we instantly can spot the difference between this is dog and this is muffins. Why? Right. This is so close.
Adversarial examples. I wanted to write about that, but there was so much research about countering adversarial attacks, but you can't. In theory, this paradigm can always be attacked, and the intuitive proof is simple. When you're doing feed forward and training the network and learning, you have 2 knowns. You have the label and the data, and you're trying to learn the classification, right? Adversarial attacks are doing this in reverse. They're optimizing in reverse. They're saying, I want this label. This is my input, right? Optimize the weights so that I can force you to classify with this label. That it's, again, 2 knowns, 1 unknown. So it's solvable. It's optimizing in reverse. You can always attack. And, it's related to something logicians talked about years ago, intention with an S, not the intention as what's your intent, the intention of something. And it's the idea is 10, the number 10 can be the output of 5 times 2, but it can also be the output of 7 plus 3. So I can always give you 2 inputs that will force you to produce 10 as a class, as an output. But what I'm giving you are 2 different objects that happens to compute to 10. And because neural networks are purely extensional by value, there's no symbolic information. There's no structured properties. Like maybe 1 spot in a cat, and you can hide everything else, tells me it's a cat. I don't need all the pixels. So there are no conceptual features. It's a blob of numbers, and they have to add up to something. And I can always attack it and make you add it up to something. But what I'm showing you is a bus, right?
And maybe so maybe the human brain has something completely different when it computes. Because if we take the materialistic view, and I'm not subscribed to this school, if you take the materialistic view, basically 1 neuron acts on the bandwidth, basically like a perceptron. What there is in the human brain that is profoundly different, that is inherently different than the sum of many neurons, axon and dendrites and activation function. It seems to me intuitively that it's not the activation function. We don't need a new modified ReLU in order to solve it. We need like a different approach. And I think that Gary Marcus put it beautifully. The AI community has the tendency of not learning from anyone, not from linguistics, not from cognitive scientists, not from anyone. And they
not everybody, but he's for the most part.
Yes. Yeah. So maybe we need, to join powers with other disciplines, with other fields, maybe with philosophy.
And this was the case before the empirical revolution took over, the data-driven, purely quantitative approaches took over. That was the case, and it was a flourishing field. We had interdisciplinary work. We called it cognitive science. We formed a hybrid discipline that was mathematics, logic, linguistics, engineering, computer science, psychology, and by the way, a lot of the great ideas are from philosophers, especially philosophers of mind, philosophers of language. That's not to say that statistics and empirical science is not important. It's part of the equation, but alone, we went too far. The pendulum has swung too far. We went too far in our extremism, like it's all data, it's all experience, observation, learning, bottom up. Not everything. Take it easy. The most brilliant, penetrating minds in the philosophy of language and mind over millennia were not all stupid. Come on, take it easy. I mean, Immanuel Kant was not stupid. Gottlob Frege was. Bertrand Russell was not stupid. He did not waste his lifetime on nothing. So it became too extreme, and now we're still living that. Although I suspect very soon it will rebalance. We are starting to see the limits of, because we're reaching.
And you said the law of diminishing returns. Your prediction in our conversation was that GPT-5 will be much less impressive than what we anticipated.
Or at least the jump from 3. There was a threshold of scale that we needed to reach. I mean, the difference between 3 and 4 is qualitative. But now you will not see. Now you will not see that jump anymore. And the limitations, the explainability, the hallucination, the failure in real deep reasoning, that will not come with scale. Sam Altman said that much, by the way, twice. He said, any new improvement is not going to come from scale. And I have a feeling this was from what his scientists and engineers were telling him, that we tried it on bigger, guess what? That's it. We got. Okay. So because I know how this thing works roughly, I mean, there are many secrets that they haven't told anybody, but the paradigm, at least, I know the architecture. And usually anything that's data-driven, there's a ceiling to how much you can get from data, and then it plateaus. That's it. I think we're gonna very soon get to a point where, and we're starting to realize that, okay, there are things we cannot just get from more and more data. We reach the limit. There's stuff outside the data. So even now, who will use GPT-4 in the enterprise if it's mission critical?
No,
I will not use
it. No. I totally understand what you're saying. It seems to me that there is one question underneath everything in our discussion, in the entire AI community, which is, what is the meaning of being human? What is the meaning? What is the difference between me and this LLM?
You're asking a mortal like me, what's the meaning of being
No. I think humanity ponder about this very question. What is the meaning of being human? What is the meaning of understanding? The idea of NLU, it seems, according to Jewish tradition, when God created Adam, he said, okay, and you can speak. So according to Jewish tradition, what distinguish Adam, what distinguish, human beings from
from
animals
other species.
is the ability to speak. So this is our...
We say first there was the word, right?
Yes, definitely. So basically the idea of speaking, if computers, if models, if LLMs can acquire this so precious ability, what does it mean about us? I think so. This is a very profound philosophical question that lies underneath everything. What is me? How am I special?
I have strong opinions here too. I'm a materialist in the scientific sense, but I'm very spiritual at the same time. I'm like, I like what Albert Einstein once said, my God is the God of Spinoza. In other words, I know my limits, that I'm just a dust in the wind. We're nothing. We're now, so I don't subscribe to the idea of AI duplicate humans. This will never happen. Never. We will create intelligent machines, not intelligent humans. We will never replicate the human being. I'll tell you why. A machine, no matter how intelligent it became in its calculations and computations, will never choke when it sees someone she likes.
The nephew. This is your example. The nephew of the 5 years.
Right.
I thought, when I heard your example about the nephew, I said, wow, what a great uncle Walid must be. This is basically because when I see my nephews, yeah, no, but it's not humans. I just listened to your nephew example today on my way and I said, wow, he must be a great uncle. I swear
I love my nephew.
This is what I ask.
I love him, and when I see him, the hug he gives me. There are machines have a machine will never feel pain or feel suffering or feel. So when people talk about machines superseding him, okay, in chess and anything that can be computationally right, but humans are not just a computational engine, right? So, and people, when I say this, they say, but I thought you're agnostic. You're not religious. This is not about religion. This is about fact. We have something that is not mechanistic, and silicon can never duplicate. So we will create intelligent machines that will and I love Chomsky's example.
By the way, it's not just silicon, and it's not just carbon based. I think that you and I agree that we don't know how to name it, but there is something beyond carbon based.
Yes. That what is it? I mean, that it's like otherwise we could have created artificial bodies, artificial humans. This creation.
My friend, you're the materialistic among us, so you need to give answers. I feel
I'm a materialist in explaining phenomena. Like I don't resort to superstition and all that, but like I said, I'm a very spiritual person in the sense that we have no clue. We're that much. We're not even. But the idea that, and people say, but machines now can do this. Wait a minute. We had bulldozers years ago, and a bulldozer can lift more than me. Does that mean a bulldozer is superior to me? The idea that a machine can do something better than me doesn't mean anything in terms of superiority. Who's superior here? I mean, I cannot lift what a truck can lift. So a truck is superior to me as a human entity. That's delusional. That's like, so even if machines can now do mental things better than us, still, our superiority comes from somewhere else. We can always pull the plug.
Yeah, definitely. Now, listen. First, I scheduled to just 1 hour, and I'm terribly sorry that
That's
uh,
okay. No, don't
but it
worry.
was
I'm enjoying it. Don't worry.
so fascinating, and I must ask you, in the conclusion, and I have a very strong intuition that is going to be a second conversation really soon because it's just fascinating. But if our viewers got to this far, 90 minutes into the conversation, and they want to expand their wisdom and knowledge about what we just discussed, could you please suggest 1 or 2 books that they can read and say, okay, this can be good? I can suggest Rebooting AI by Gary Marcus, which is a great
Yeah,
book. And
rebooting AI is one of the new ones. I'm gonna go with older stuff.
yeah, I know, because you are you love Fergal and Russell.
Not that old, in the middle. Let's go in the middle.
Okay.
I would recommend Society of Mind for Marvin Minsky.
Oh, this
Beautiful,
is a great
beautiful.
book.
Yes,
I
beautiful
think
book.
that I have it right now. Just a second.
Yeah, if you can show them the cover, it's a beautiful book.
Okay, just a second. Just a second. Oh, this is Society of Mind by Marvin Minsky. Great book.
Beautiful book. What a and he is a great writer. He writes at the level that anybody can understand. So I would say definitely read this Society of Mind. I subscribe to his idea that you have to create all these modules, little modules that are specialized in different things, and then we have a society. The mind is a society of interacting modules. So you have a module that specializes in color interpretation, a module that is excellent at shape analysis, and so on. Beautiful book, definite recommendation. The other one is
give me another one.
Yeah, I'll give another one. Is again one of my heroes and idols. He's a little bit tougher. He's a very he's not always easy to understand, but he has a nice book called The Modularity of Mind. So now we have Society of Mind and The Modularity of Mind, and that's Jerry
by Minsky.
Jerry Fodor, who is one of the most prominent cognitive scientists. I mean, he's at the level of Noam Chomsky and Steven Pinker, and a great thinker. So these two books are a very beautiful introduction to AI/cognitive science. And I shied away from the engineering AI books. I have a list of those, but I think that is these are details. First, get the conceptual framework, what was the debate all about? What are the real issues here, right? Then you can, there are so many computational books you can.
Okay, thank you so much,
Walid
oh my God. Saba. It was a
Thank
wonderful conversation. Thank you so much.
Thank you, sir, for the invitation. And maybe we'll continue offline. You mentioned maybe writing things together and so on.
Yeah, and it will be my great honor.
Let's continue the discussion. And I really thank you for this opportunity. So, guys, I think that this is my true privilege, speaking with so many genius and articulated people from all around the world, discussing science, philosophy, artificial intelligence, religion, and more. If you enjoy this conversation, please consider subscribing, hit the bell button, and be part of this great community. Until next conversation, I was Roy Yotzevich. Thank you, Dr. Walid Saba. Thank you, sir.